Good morning. Mitch from Arista, joined by the one and only Diego and Sayantan. Diego, Nokia, Sayantan, Keysight. And we are here to talk about exactly what Tarek just brought up, EVPN Gateway with DPath. So going back to the test itself, what did we set up? What did we actually test? What was the purpose? So interconnecting multiple EVPN VXLAN domains and also making use of DPath for loop detection. Of this, we're making use, it's standards-based, so RFC 9014, and the drafts are listed up on the screen. And kind of begs the question, why would we do this? Why would we use this thing? And it's to introduce hierarchy, get a sense of scoping of control plane state and scaling between multiple EVPN domains. And we have the ability to leverage all-active multi-homing for gateway resiliency, as we'll see that in the demo. So then from there, we get all-active forwarding, and that's where DPath is going to come into play for our loop detection. All right, again, so jumping right in here, that's why would we do it, but how does it work? So, improving scale, how we have the topology. Here we have domain 1, we have an interconnect domain, and we have domain 2. Interconnecting those domains are these gateway nodes. Okay, cool. So we have the gateway nodes, interconnecting them. What do these things actually do, right? So they take the routes in, and as we'll see in a second, we'll do a control plane walk of the routes as they're being advertised and re-originated. But for example, the type 2 route comes in from VTEP 11. Gateway 1 receives it, cool, imports it. It'll re-originate it with its own RT and RD values. We'll see they can be the same as the local domain. They can be different as they're advertised into the remote domain. We have some flexibility there. And then it sends it on with its own VTEP IP as the next hop. One of the benefits here is that it removes the requirement for end-to-end underlay reachability for VTEPs in all the domains. So in our example here, we have VTEP 11 and VTEP 31. There's no need for those two VTEPs to have end-to-end underlay reachability to each other. They really just need to be able to have reachability to the egress gateway node that's at the demarcation point, the edge of their respective domain. All right, routes, and more routes. Where do these things go? How do we scope these things? So we'll go through a little fun scenario here, get the party started. So type 2 comes in, VTEP 11. This will be re-originated by the gateway. Gateway re-originates it, uses its own RT-RD values. Can be the same as the local domain, can be different, have that flexibility. Gateway 2 receives it, says, all right, cool. I'm going to re-originate this into my local domain, domain 2. VTEP 21 gets it, and he's ready to party. All right, type 3, so our IMET routes. Gateway VTEP 11 advertises this, hey, add me to your flood list, please. For this EVI, aha, do not pass go, do not collect $200. It does not move on. However, the gateway nodes, if they have an EVI locally instantiated, let's say VLAN 10 or whatever you want to call it, they're going to originate their own IMET route, type 3 route, for that EVI and send it to its remote domain peers, right? So in this case, gateway 2. That way, gateway 2 could add gateway 1 to its flood list for that respective EVI. Then from there, gateway 2 originates its own into its local domain. And then we have all those fun multi-homing routes. There they are. And once again, they do not pass go. And that's the scoping of the control plane state. Now we could add type 5s to this as well. Those would be re-originated, same behavior. We can re-originate the gateway with its own next hop, and then its own configured RD-RT values when it re-originates that route. But for this, we're going to focus on L2. So, what about DPath? That little fun slide a second ago where we looked at all the routes, DPath wasn't on there at all. Where does this come into play? So this really identifies what domains a route has passed through. So extended community, we can kind of see, and we'll take a look at the control plane in a second, see the DPath value of every single domain that the route has passed through. Very good. How can we use this? Detecting loops, but also best path, right? So for example, a shorter DPath will win the day. All right, let's go through that example again, and now with 100% more gateway. So, type 2 comes in, hits gateway 11, takes that type 2, re-originates it, sends it into the interconnect domain. Next hop of gateway 11, dpath of 1:1. Gateway 21 receives it, says this looks awesome, import this, I'm going to re-originate it and set it in to domain 2. Dpath gets added in there, now it's 3:3, 1:1. But wait a minute, in the interconnect domain, when gateway 11 sent the type 2 route into the interconnect domain, that is inevitably going to come back over to gateway 12, who looks at it and says, all right, next hop, it's a valid route, looks good, I'll accept this thing, I'll import it, cool. But, dpath, I am attached to that domain. No, I am not going to send this back in to the local domain because we know that's where it originated from. All right, with all the fun concepts and theory stuff out of the way, we'll actually go into the live demo. So our topology here, we have domain 1 on the left, domain 2 on the right. We have their dpath values listed here for reference. And in domain 1, we have 2 VTEPs, and we have 2 gateway nodes that are in the all-active gateway resiliency model, we'll call it here. So they have the interconnect ESI that's shown with that all ones. And then on the remote side, we have another gateway node, single home on domain 2. And then we have a VTEP over in domain 2 as well. All right. Now, let's go ahead and switch from this mic to this mic so I can actually type. Testing. All right. All right, so we are going to jump into, let's get this microphone right here. So we're going to start by jumping into, let's hop on this PE11 right here. So this would be the gateway 201 over in domain 1. Hop over here, take a look, and clear the screen, and take a look at show VXLAN flood VTEP domain local. All right, he sees in his local domain 202, 3, and 4. All right, if we look back here, that makes a lot of sense because 202, 3, and 4 are all in the local domain. Come back here and we look at remote. We see, 56. So there's Nokia hanging out over there in domain 2. So we see that it is added to the flood list for the remote domain. And if we take a look over here, clear the screen again, get some real estate. So show BGP EVPN instance, and let's do VLAN 1301. Which is the bridge domain we'll be using for our testing here. And let's take a look at some of this output. What are we seeing? So we see that we have the route distinguisher values, so for the local domain and also for the remote domain. So these are the same. Could be different. Same here, we have for the local domain RT values, we have 1301, 1301. But when we are doing import or export operations with the remote domain, we're going to use 65205, 1301. So again, these could be the same. In our case, we're going to make them different for this demo to showcase that. The remote ES, so Ethernet segments, we see in the local domain. Well, actually, this one's in the local domain. And we also see the remote domain, so active TEPs with the interconnect ESI of all 2s. And locally, we have the interconnect DSI, which we'll see is tied to interface VXLAN 1. It's kind of a logical construct here. And we have a designated forwarder. And so in this case, it would be gateway 202 is elected as the DF. We're using preference space for that. And that is on the interconnect ESI value defined here, which is all 1s. All right, so let's go ahead and take a look at some of the control plane state that's being generated. So I grabbed a little example here of the MAC address that's in play. And let's go ahead and jump on gateway 201. Actually, jump on the spine and run this. There we go. All right, so looking at this MAC address, so we'll go ahead and zero in on this one over here. So this MAC address actually exists over in domain 2. And even when we're looking at the control plane state on the output of the CLI, it's helpful to see DPath. Yes, DPath can be used for loop detection and for best path, but it's also helpful when you're kind of looking at a route. Where did this come from? What domains does it pass through? You can tell very quickly this came from domain 2 because the DPath value is on there. All right, so that looks good. See, next hop is 201, which looks good. It is the local domain RT value. So far, so good. If we look at this same information over on, so this is the spine over in domain 1. So looking at that topology, we were running that command right here. Let's run it from the gateway node and see how different the control plane state looks for that MAC. All right, so we see that it ultimately arrived from 56. And so as it came from the remote domain, we can see that we have the RT values and RD values. 1301, very good. All right. Last but not least, let's go ahead and clear this off. And let's make sure traffic is actually passing, right? So if we look at the forwarding entry on this node here, let's go ahead on the gateway 1, and let's go ahead and just quickly use this guy right here. All right, so pop this into gateway 1, or 201, and we see, all right, if I want to reach this MAC that is over in domain 2, it's going to be VXLAN end-capped and sent over to 56, which is Nokia, which looks perfect. So with this control plane state that we're seeing here in the programming and the fib, we should see that the flows are running. And one of the ways to validate that is we can actually do a PCAP on the fly. PCAP where it didn't happen, right? So let's go ahead and see the truth is on the wire. So fire this up and bring up Wireshark. Take a look at this. And there we go. And we see, if we look at the packet itself, make this a little bit bigger, zoom in some. There it is. So we see in this direction, it is node 201 doing the end cap, sending it to 56 to Nokia. And if we take a peek at the VXLAN header, this should be bridged, and it is. 1301 is the VNI to be used here. And we see the inner Ethernet and IP headers look as expected with the original MAC and IP. And yeah, all looks good. So without further ado, I will hand it over to Mr. Diego.
Hello everyone again, my name is Diego. Thank you very much, Mitch, for a very eloquent presentation. So what we wanted to show you from the Nokia side here is just a bit of control plane information too. So first of all, I just wanted to show you a few roads. For example, in this case, the layer 2 roads that we receive on the one side. So as you can see, they are tagged with a specific road target. So we see that we receive those roads from the remote gateways, and they are resolving, or they are being announced with an ESI. So then this gateway is going to use that ESI to spread packets across those two gateways on the remote EVPN VXLAN domain, right? So we have that information in there, and just basically the next thing I wanted to show you is so how we use this information to build the flooding. So let me just remove this detail here. So we see that we have discovered a few VTEPs in this case. Let me just do this here a little bit. No, okay, I'll leave it like that because it looks like, yeah, okay. So we have a couple of VTEPs here, like we have the EXIA VTEP, and we have a couple of Arista VTEPs in here. So we have the flood list built based on the reception of those EVPN routes. And then we see that we have also an ESI from the remote gateways. And then finally, what I wanted to show you is the FDV for that specific bridge domain, which is, as Mitch was mentioning, is the bridge domain 1301, which is the domain being stretched across multiple DCs over the network. So we have the forwarding entries in there. As you can see, we have a couple of MAC addresses being received from the remote gateways, and that MAC is pointing to an ESI that is finally going to resolve to these two gateways. So that is all the information we wanted to show you on the Nokia side. Now I will pass it to Sayantan to show you the flows that we have in IX network. So let me just, there you go. Thank you.
Thank you, Diego. So now I will explain Keysight's role in this demo. So there are two Keysight ports which are connected to two extreme ends of this topology, right? And the first one you see here, this port. So this is basically simulating host which is connected through a harness switch to two different Arista VTEPs which are multi-homed. And on the other extreme end, so Keysight is emulating PE, the VTEP, as well as the host behind it. So if we just take a look at this IP address here, this is 10.30.1.203. So this is on the left side of the topology. So and this host would be ultimately advertised by Arista VTEP using MAC IP type 2 route in EVPN. And on the other side, so we have another IP address, another host having IP address 10.30.1.103, which would be advertised by the Keysight VTEP itself, right? And also, if we take a look at the control plane of the Keysight VTEP, we see that it has learned the IP address of the host, which is on the other side, right? 10.30.1.203. And if we look at the next hop, right, 100 and 0.0.56, so this is learned from Nokia's gateway. And finally, let us take a look at the traffic statistics here. So I'm sending bidirectional traffic between these two hosts, and we can see, there is no loss or, anything. So traffic is flowing fine. So with that, I would ask Mitch to come on the stage and have some concluding remarks. Thank you.
All right. And so kind of recapping here what we've covered, we've taken a look at the EVPN gateway functionality, scaling between the different EVPN domains, DPath, loop detection, best path selection, also helpful in the control plane to see what route, what domains the route has passed through if we're looking at the route. Saw how the routes were scoped. One note here, so this reorigination of the type 2 by that gateway node, that's only going to happen if the EVI is configured to be stretched, right? So it's not just going to take every EVI that's locally instantiated and reoriginate every type 2. They'll need to be actually configured to say, okay, we're going to enable the kind of remote domain for this respective EVI, so it's stretched in that case. But outside of that, nothing else to add. Diego, Sayantan, you guys rock. Thanks, everyone. That's it.